All right, I am recording this presentation and we will plan to post it onto the Institute for the Environment's YouTube channel in the next couple of days. So I want to welcome everyone for joining us today for a kind of a lunchtime discussion about floating solar photovoltaic systems. I recently learned about these myself. I really didn't know they existed until maybe a couple of months ago. And in doing my research, I came across the work of Alexandra Aznar, who works at the National Renewable Energy Laboratory. So I invited her to join us today to share a little bit about this technology and where it's being deployed both in the US and around the world, and to also give you the opportunity to ask questions. And many of you have already done that through Padlet. And she has viewed your questions. They're going to be incorporated into the presentation, and then we'll have time at the end to answer your questions. So my name is Dana Hain. I am a science education manager for the Institute for the Environment at UNC Chapel Hill, and I'm program director for the North Carolina Energy Literacy Fellows Program, which is a teacher professional development program that works to enhance energy literacy of STEM teachers across the state, so that in turn, they can enhance the energy literacy of students across the state of North Carolina. So we have many teachers on the webinar today, as well as many students. And you'll notice this is a webinar, so it's a little bit different if you're used to Zoom rooms and all. This is just a Zoom webinar session, so it's a little bit different. You'll notice there's a Q&A box, and this is where we would like for you to place questions that you have for our presenter. And if you have other things to say, technical questions, etc., please use those for the chat. And please try to just minimize your use of the chat just so people can focus on the presentation today. So I'm happy and delighted to introduce you to Alexandra Aznar. She's program manager at NREL. She's going to tell you a lot more about herself, and it will be much more exciting than if I introduced her. So welcome, and thank you so much for being here today.
Great. Thank you, Dana. Just checking. Can everyone hear me? Yeah? Okay. Yeah, so thank you so much to Dana and her team for reaching out and inviting me to talk to you all today. And thank you for taking the time from your holiday to learn a little bit about floating solar. So my name is Alexandra Aznar, and I'm a program manager at the National Renewable Energy Laboratory, or NREL. And let's just dig in. I think I'd like everyone to just take one moment and remember this picture of a floating solar system here on this front page, because we're going to go through the presentation, kind of come back to that. Okay, let's see. So I'm just curious if folks on the call have heard of NREL before or know where it's located. And I know you all have access to the internet right now and can Google it, but I'm just curious if folks have heard of NREL before. If you want to type in the chat and take a moment. Okay, some folks have. That's great. Oh, some folks have even visited. That's wonderful. It's a very beautiful campus. Okay. All right, so we've got a mix of folks who've heard of NREL, some who haven't. So I'm going to tell you a little bit about my background and a little bit about the lab that I work in before launching into the actual content about floating solar. So a little bit about me. I have a background in public policy and energy. And so I think sometimes people think when you work at a national energy laboratory that you must be a scientist or engineer. But actually, we have folks from a variety of different backgrounds working at the laboratory. And so some folks have backgrounds in business administration or finance, or in my case, public policy. And we all work together on kind of holistic teams to solve some of these energy problems. So that's one thing I just wanted to emphasize for folks on the call, is that whether or not you come from a STEM background, there still can be a role for you in the clean energy space. So I work in a center of NREL called the Integrated Applications Center. And this center is focused on taking the technologies that are developed at the lab and moving them out into the marketplace. And so we know that that's kind of a big leap for commercializing these technologies. And so again, I work with groups of engineers and people in finance, policy, to figure out, well, what are those barriers, the financial barriers, the regulatory barriers that we need to overcome in order to get these technologies into the marketplace. And during my time at NREL, I've worked on a variety of projects domestically, so with cities or state and local governments, but I've also increasingly worked on projects in the international space, and I can talk a little bit more about those too. So I wanted to talk a little bit about NREL for those folks who aren't familiar with it or haven't been. This picture in the background here is our campus. We are based in Golden, Colorado, which is just west of Denver. And we've got almost 2,000 employees who work at the laboratory. So it is a very big space. Most of us are at home right now, like the rest of you, but we do have a core team that is on campus right now. We have really a world-class campus and facilities. We've got laboratories where people are doing experiments with different kinds of partners from industry and academia, and our campus acts as a living laboratory. We actually have experiments going on about our own energy use, our own water use. We've got electric vehicle charging on campus, and we've got our scientists doing analysis on how people use that charging. And so we're really trying to learn from our building. We are a net zero LEED certified building, and try to live by example. So NREL is actually one of 17 Department of Energy national laboratories that are around the United States, but we specialize in clean energy. And these icons here on this slide kind of show you what that entails. So we focus on renewable power, most notably solar and wind, but we also do a lot of work with water and geothermal energy. We have a very large sustainable transportation center where we're working on electric vehicles, but also hydrogen and bioenergy. We have an advanced building center where we're working on manufacturing, buildings, and energy efficiency technologies. And then an energy systems integration center where we're trying to figure out how to put all of this together. Okay, so that's a little bit about NREL and myself, and I'm happy to answer some questions at the end of the presentation. But I wanted to launch into floating solar. This is one of my favorite photos to show when I talk about this topic. I want people to study it for a moment, and if you type in the chat, what's going on here? What do you see or observe in this photograph that is interesting, unique, unusual? Let's take a moment for that. All right. There we go. Yep, if people look closely. Great. So yeah, some of your observations are spot on. So this is actually the same floating solar array that you saw on that first slide. Now that first slide was during the daylight when the sun was shining. And this is a floating solar array that NREL actually helped develop in Walden, Colorado, which is up near the Wyoming border. So it is a very cold place in the winter. And this was taken from the video footage at the water treatment plant in Walden, Colorado, where this system is located. In the winter at night, it is frozen, and there are two curious foxes that are walking over the ice and exploring the floating solar array. So I think this is kind of an interesting anecdote that raises some of the issues we're going to talk about later in the presentation. Okay, so I just wanted to start with a basic figure here to answer that basic question: is what is floating solar, or sometimes we call it floating PV or FPV for short. And really, countries around the globe are exploring ways to complement their existing power generation mixes with low-cost PV. And solar PV or floating solar can be part of this strategy. And these are really an emerging opportunity where you're taking solar PV systems and you're siting them directly on water bodies. And so this figure is an example of the key components of a standalone large-scale system. So you've got the PV modules, and these are generally the same kinds of modules that you're going to see in a land-based system. But when it comes to floating solar, these systems are mounted on floating platforms that are constructed from plastic and stainless or galvanized steel, instead of the fixed racks that you see on land-based systems. And these floating platforms are really similar to buoys that are used in sort of in docks and marines. So that's going to be, if I can show these gray parts right here. So these panels aren't exactly directly sited on the water. They're on the floating buoy, and there are walkways between the rows that people can use for access and maintenance. So as I mentioned, you've got a series of these modular platforms, and then they're connected together with these designated pathways. The platforms are then connected to mooring lines that are, these are right here, that are either connected to the shore or the bottom of the water body or floating anchors. And then the system is connected to the main electrical equipment, and this generally resides on shore through underwater cables. Now, we got a lot of questions in the Padlet about where these systems are deployed, what kind of water bodies. So to date, these systems have been predominantly installed on artificial water bodies. So these could be wastewater treatment ponds or reservoirs or agricultural irrigation or retention ponds. And this helps avoid some of the potential environmental impacts and other siting complications if you're deploying these on natural water bodies. Now, there are a couple of pilot projects where we've seen small floating solar systems on kind of an inland bay area on open water, but these are not deployed out in the ocean for a variety of reasons. One, just technically, it's very challenging. You have to deal with a lot of high waves, movement, storms that don't really make these practical. And so unlike offshore wind, where you are siting those systems quite far from the shoreline, floating solar is really more practical right now. Again, this is an emerging technology, but right now on inland water bodies that are just calmer than the open ocean. Okay, I wanted to throw a couple of polls into the presentation. And so now that we kind of know the basics, I wondered if people know where is the most floating solar deployed as of today. So this can be a country or a region, your best guess, and which country has the largest floating solar system. And so I can see we've got a question popped up in a poll pop up in the, so if everybody could answer that. Okay, I'm not sure if the questions are or the answers are coming in somewhere.
Hi, Alex. So
Hi.
I'm seeing the polls coming in. I'm not sure if you were able to see them or not.
I don't think so.
Okay, so I can tell you we're about at 83% of people have answered. So maybe we'll wait a couple more seconds and then I can share, or I can tell you the results of the poll.
Oh, perfect. Okay, thanks, Victoria.
Okay, looks like we're topping out at about 84% response. So looks like 36% of participants, let me go ahead and end this. So 36% of participants selected China, another 36% selected United States, 26% selected Japan, and 2% selected India.
Okay.
I think I can share the results. Oh, there we go. Can you see
that? Yeah, there you
that?
go.
Okay.
Very interesting, yeah. Excellent. All right. Well, thank you for participating, everybody. I think we'll skip to the next slide to really unpack that question. Let's see. There we go. So the question can be answered in a couple ways. We do see the most floating solar in terms of installed capacity. So that's in terms of megawatts, and the number of systems, which could be, you could have very small systems in Southeast Asia. And China is home to the largest floating solar system in the world, which is currently 40 megawatts. Japan was an early adopter of these systems and has, small systems throughout the country. But they're really a leader, although you do see these systems deployed throughout the UK, Northern Europe, and in the US as well. But Southeast Asia is leading historically, and most floating PV systems are expected to be developed in that region. There's also growing interest in combining floating solar with existing hydropower systems. And a lot of those systems are in regions of like Southeast Asia and Latin America. So if you look at that graph on the left, in 2007, the first commercial floating solar installation came online at a winery in California. But the vast majority of these systems have become operational since 2014. So that's not that very long ago. These are still new, and we're still learning a lot about them. So the deployment of the floating solar systems is accelerating. We've got a global installed capacity up from below 1 megawatt in 2007 to a little over 1,300 megawatts in 2018. And we're really expecting that to continue to approximately 13,000 megawatts by 2022. And you can see some of those projections in that graph over on the right. And so a big reason that a lot of these systems are located in Southeast Asia is because of the high land cost and the constraints to land availability. And also, as I mentioned, there's a large prevalence of hydropower generation and a lot of interest in pairing these systems with hydropower. Okay, so I kind of touched on some of these already, but I wondered if folks wanted to put in the chat, now that you know a little bit about these systems, the basics, why would you consider pursuing floating solar, or why not? So trying to get at what may be some of the benefits or the issues with this technology. Get a couple of ideas and then we'll unpack them. All right, I'm seeing some really good answers come in. A lot of people are referring to dual use, so looking at how we can use an existing water body for energy generation and constraints with land availability. All right. All right, well, thank you so much. Let's dig into some of these. All right. So on this slide, first of all, this picture is from a floating solar plant in Japan. A colleague of mine had the opportunity to go visit this site in Japan. And this slide is really showing in those bullets some of the motivations for deploying floating solar systems. And a big one, again, is that first bullet, trying to avoid land energy conflict issues. So, we have a lot of land in the United States, so we don't necessarily have this problem, although that varies depending on the region. But a lot of the countries around the world, particularly ones NREL is working with right now in Southeast Asia, do have a lot of land energy conflicts. So land may be prioritized for growing food, for example, and people don't want to have a large solar plant on the land. So can we shift that energy generation to an existing body of water? That's one of the main motivations for exploring this technology. And it's tied to that second bullet, which is generating revenue from an underutilized area, that water body. Another motivation is that there's evidence that when you place these PV systems on bodies of water, you actually increase the solar panel efficiency. And what do I mean by that? So panels operate most efficiently at an optimal temperature threshold, and they actually start to operate less efficiently as that temperature gets higher. And so let's think of like a PV panel kind of baking in the sun in Phoenix, Arizona. One would think that that is actually a great place with excellent solar resource, but when you start to get into those extreme temperatures, the panels can not operate as efficiently. And so if you put them on the water, there could potentially be a cooling effect, and you could get a little bit more generation from those systems. Another motivation, I'm going to that second column, that top bullet, is there could be some benefits to the power system overall when you're pairing floating solar with hydropower. And I'm going to get into some of those details in a moment. We've also seen some evidence that these panels can help reduce evaporation on water bodies. And that's typically a good thing. You know, I live in the Southwest here in Colorado, and this is a big issue, concern with our water bodies, although it may be less so in other areas. Another motivation for deploying these systems, that third bullet on the right, is that it typically costs less to prepare the space for these floating systems. You don't have to kind of grade the land and put these big, metal poles into the ground. These are pretty straightforward systems to kind of bundle together and then push out into the water. And then that last bullet there, there's evidence that you can have improved water quality. So these systems, can potentially reduce algal growth in water bodies, which would improve water quality. Again, some of these potential benefits are, there's not a lot of evidence for them, and we're still trying to understand them better at NREL and other folks in the floating solar space to understand. All right. But I did want to mention that despite its promises, there are many challenges and, frankly, many unknowns associated with this technology. And so, although the technology itself is not new, as I mentioned, we've had PV panels for a long time. The deployment on water is new. And so when you're deploying on water, you're exposing the panels to humidity and potential corrosion of the structures. And there could be water body contamination that could contaminate the panels. And we don't know, over the long term, what that does to the performance, the generation of those panels. Also, if you think about a floating system on those buoys, they have a constant, motion like this as the water moves. And over time, we call that material fatigue of the joints, and it can create wear and tear on some of those connectors that are holding the system in place. So the systems could potentially degrade and create performance issues. But again, we just don't know over the long term how these systems perform, because most of them have only been out and in the real world for about 6 years. So if you look at that picture here on the left, you're also going to see that there are some environmental concerns. So these panels are deployed on water, and they attract birds, and you can have a lot of bird soiling. And when you have that bird soiling, it's going to reduce the output of those systems. I saw some questions in here about the cost of these systems. Again, because these systems are so new, we don't know a lot about their costs. It looks like that capital and operation maintenance costs vary significantly across vendors and across regions. And this cost variation and uncertainty can hinder investment in this sector. And then another issue that a lot of folks raised is that there's still a lot of unknowns about the environmental impacts of these systems. And so we don't know the effect that they have on the flora and fauna in the water body. And again, we're trying to partner with folks to do research on the impacts of these. So I'm actually borrowing this slide from Dana shared it with me. It's from a really good report out of the World Bank where the sun meets the water. And I think it's just a really good summary of those potential benefits with this technology that you see here in green, and then some of the additional challenges which you see in these orange triangles. So, again, a lot of opportunities, some potential challenges, a lot more unknowns, and just a lot of space to do more research on this technology. Another thing to think about when you're deploying this technology is, its capacity to survive storms and be resilient. And so these pictures are from some storm-damaged floating solar systems outside of Japan. Again, you can design your systems to withstand certain wind loads, but if you're going to have these typhoons and these hurricanes, there is the potential for significant damage. I wanted to talk a little bit about this idea of pairing a floating system with a floating solar system with a traditional hydropower system, and what some of those potential benefits could be, because this is of interest. So there's different configurations of this, but there are improved operational benefits. So I'm going to give you, the example of Colombia, which is a country NREL is working with in partnership with one of our clients. And they're really thinking about combining these two technologies because of improved system operation. And so in Colombia, they are highly dependent on hydro. And during the rainy season, that's great. They have significant hydro power and can generate a lot of electricity. During the dry season, however, there can be a shortage in some of those dams in the water. And so floating solar is an excellent complement, because during the dry season, it can generate a lot of power and maybe reduce the need to use your hydropower resources. And then in the rainy season, you have excess power from your hydro, and it's actually you're not generating as much solar from your floating system during that season. So there's a real compatibility from a seasonal perspective, and sometimes from a daily perspective too, because we know that PV systems are generating during the day when there's sun. So you could be reducing your hydro output during the day and then releasing that hydropower at night when the PV is not generating. Again, just an example, we call that a system operation benefit when you're combining these different technologies and getting better results because of those combinations. That second check on the box I've already talked about a little bit. If you're generating energy from these PV systems, you can store more water for later use. Also, another thing to think about, this is getting a little bit wonky, but when you have these large hydropower systems, they're connected to a transmission system. And these transmission systems carry that electricity from that hydropower dam to a load center. So this is a city where people are using that energy. And sometimes you don't have a lot of energy systems on that transmission line. But if you can add more systems, you increase the utilization and you kind of lower the cost of that investment. So again, you just have opportunities for reducing system costs, but there still are deployment challenges, and we're still learning a lot from the field of how these systems perform together. So I wanted to skip to some recent analysis that my colleagues and I have done at NREL on this topic of floating solar paired with hydropower. And we did an analysis using publicly available data to estimate what the global technical potential of hybrid hydro floating solar systems would be, subject to certain constraints. And so this map illustrates the result, and it indicates there's significant potential globally for floating solar combined with hydropower. And this is ranging from 3 terawatts to 7.6 terawatts for different scenarios that are considered. And so you see in these maps, these circles are showing kind of the technical capacity of those systems, which is going to be based again on the availability of hydropower and the solar resource in these areas as well. And this report is actually in the final slides, so I encourage folks to go look at it. I wanted to share one more analysis that my colleagues and I have worked on, and this was really looking at technical potential of floating solar in the United States. And I know this term is kind of a new one to folks, but you're looking at technical potential, you're looking at what's technically possible in an area, not necessarily what's practical or what is actually going to be built, what's economic, but really in a region giving some topographic limitations. We're not going to build a solar system on a very steeply graded piece of land, but where else could we build it? And so this work is summarized in this report here. We took an approach of looking at dams across the United States, different water bodies across the United States, and we eliminated ones that are used for recreation, navigation, wildlife. So we're really trying to be conservative here and only look at water bodies where we think, practically these systems could be deployed. And then we were able to match that with solar data and come up with these results. So this map here is showing, geospatially, state by state, that floating solar systems that cover just 27% of the suitable water bodies we identified could produce almost 10% of the US current national electricity generation, or about 786 terawatt hours a year. And so we're not assuming that you put these systems on, the entire water body. We were really being conservative, saying you keep a limit there. But this is showing some of the states where that generation is the greatest. And again, this is a factor of, one, how much water availability is there in the state? And then what is the solar potential? So I'll give two examples, contrasting examples. One is the state of Florida here. We know, Florida is a very sunny place, so it's a great place to deploy solar. So that's going to definitely, increase the amount of potential for these systems. But you can see that it's the same level as Minnesota, which is not necessarily, it doesn't have necessarily the best solar resource, but it has a lot of potential water bodies. And so this analysis was really balancing those two factors to come up with these calculations. One other thing we did in this analysis was look at the potential of these systems to reduce evaporation. And so again, we're looking at the kind of water bodies and the greatest area for that. And so that's going to be in the Southwest Florida and up in Minnesota. The figure on the right is we're looking at areas where land costs are the highest because of the hypothesis that if land is expensive and people want to use it for other things, then there could be greater opportunity to put floating solar on water bodies.
Alex, I think your slide didn't advance. If you'll advance it, we're still seeing the US map.
Okay, can you see these two maps?
No. There was a little delay and I thought it had been corrected. There we go.
Okay.
We can see them now.
Okay, so let me go back to...
Yeah, maybe just pause here so people can look at it.
Okay, so if we look on the map on the left, we estimated the net evaporation rate for each of these feasible water bodies in the US. And so the dot color designates sort of the evaporation rate, and the dot size is proportional to the annual evaporation by volume from the reservoir. So we're looking at where is really the biggest bang for your buck. If you were to put these PV systems on water bodies, where are you going to get the most reduced evaporation? And again, this kind of intuitively makes sense in the Southwest, where you have those high evaporation rates from water bodies because of the climate. And then the figure on the right, as I mentioned, is estimating land values across the US to understand where floating solar may be attractive, because you're going to put it on water instead of land. I know this is a lot to take in. It's a pretty technical report, but I encourage folks to get a copy and dig in. We also have an interesting video that is at the end of these slides that you can watch to learn about this. Okay, so I just wanted to jump to some of the other research areas that NREL is focusing in. Again, there's so much to still unpack with this topic. We're working on analysis, so we're really trying to understand, how does floating solar impact the power system operations? What kind of benefits does it provide? What are the costs and benefits of locating floating solar with hydropower? And do we need to build some special tools for analyzing floating solar? We're also really interested in implementation and doing more work with partners who are implementing these systems and monitoring and evaluating them. So at NREL, we've been monitoring and evaluating traditional PV systems for over 40 years. But again, most of the floating solar systems that have been deployed today have only been deployed in the last decade. And so there's a real need to understand how do they perform over time, and we're trying to do more work in that space. These are some just examples of some ongoing research that we're working on, trying to understand floating solar co-benefits. We're doing more and more of these technical potential assessments. So I showed you one that talked about nationally, what's the technical potential for floating solar. But a couple years ago, we worked with the state of Colorado and did a detailed analysis looking at different water bodies in Colorado and understanding the potential for floating solar. And that was with the Colorado Energy Office that is very interested in these systems. We're also trying to do some more work with floating solar hybrid system modeling, so understanding how that hydropower system and the floating solar system would work together. And then some of our latest work is looking at the reliability and the degradation of these systems. So again, because of the siting on water and the exposure to humidity and other kinds of elements in the water, how do these systems perform over time? Here's just a couple of additional resources. I've got that technical report that I referenced. This is a really great report from the World Bank. This video here, I think, can give you a little bit more information about the system too. And that's really all I have today. If you want to contact me, sorry, this is a typo here. It should be AZNAR. Feel free to reach out and I can put you in touch with other colleagues and provide some more resources about this topic. And so now I'm happy to turn it over to folks who have been monitoring the Q&A, and I'll try to answer your questions. Thanks for listening.
Yeah, we had a number of questions come in, and I'll try to kind of go through them. You can keep adding questions. You can also upvote questions if you see a question that you really want people to answer. But thank you so much for that overview. And I'm gathering from the questions that this is something that's new for a lot of people to be thinking about. And I am really intrigued about in thinking about the the potential challenges to this technology and the things that we don't yet know enough about. Like for me as a biologist, thinking about the aquatic life underneath the panels, that's something that would be of interest to me. So let me just see. I know one question that I think one thing we want people to maybe realize is that these floating solar systems are technologically very similar to land-based systems. So maybe you can just address that. We had some questions come in about how long they can last for and about maintenance. But then you also did address the special, the floaters, that hold the panels up. And so there's another material that can impact things too. So if you want to maybe speak to that a little bit, just the lifespan and the maintenance cost, and maybe comparing the cost between the two.
Yeah, absolutely. So these are indeed the same exact panels that you would be using in a land-based system. But obviously, you know, in a land-based system, if you think about a system on someone's roof or out on a larger piece of land, they're attached to these metal structures that are bolted onto the roof or the structure on the land. And with floating solar, they're actually placed on these floating buoys, and that's how they're connected. And those have to have some give for the water body. So the actual technology is the same, but sort of that substructure is different. And then how the panels are going to react is different because it's actually moving, it's getting more exposure to that water humidity. I mean, obviously, with land-based systems, they're exposed to rain, hail, and other severe weather. But floating solar is a little different. Now, in terms of the cost, this is a really interesting question, and we're trying to understand more about it. Costs seem to really vary compared to land-based systems. There's evidence that the operation and maintenance costs may be lower, that it's pretty easy to just walk through those rows between the panels and wipe panels off with some water. The water's right there, right? So fairly easy to clean. Also evidence that there could be lower capital costs because you don't have to do as much land preparation. But because it's such a new technology, you know, finding these buoys, finding firms that are able to design these structures properly, there could be some additional costs there. So again, just a lot of uncertainty right now. And we do a lot of work at NREL tracking the costs of PV systems land-based, and we'd like to do more with floating solar.
Yeah, and so could you speak to, and maybe you said this, but if someone wants to make a solar farm, how do they decide? I guess they have to think about other land use. In terms of deciding whether they put it on a lake or they put it on land, they have to think about what, I guess, the competing land uses might be. Is that how they would decide which to pursue?
Yeah, that would be one way to do it. So a lot of the analysis is the same. So when you're thinking of developing a solar project, you're typically starting with some initial modeling, and we've got a lot of tools at NREL for that modeling, where you're looking at the solar resource to the site, you're looking at the current electricity rates that you pay to see how solar would offset that energy. You're looking at the kind of energy that you currently use, your load, to understand how that system would help save you money. So you're kind of modeling that, and you're going to get an estimated amount of generation annually that system would produce, and then a certain cost for that system. And again, that can vary on geography, where you are, but a lot on the electricity tariffs and just other public policies, right? Maybe some of you have heard of net metering, for example, which allows you to sell your excess solar energy to utility. And that's going to affect your cost over time, whether that exists or not. So you would do the same kind of analysis, but then, you know, if you wanted to consider a floating solar system, some of those cost assumptions might change. And so it could be more or less expensive. And then you'd have to look at, you know, that competing need for the land if it's going to be used for something else. And so actually that first system at the winery in California, this was a very small project, again, a private landowner developing this and deciding that that land use was more valuable for producing wine versus energy, but they had this small water body and they wanted to try to get some, you know, clean, affordable electricity from that. So that went into their decision making.
Yeah, great. Gloria asked, I noticed that the higher numbers of floating systems in the drier states where water is at higher risk in quantity and quality. Am I seeing this correctly? So it looked like maybe based on your map, there was higher potential in some of the drier states. So maybe you could speak to that.
Let me go back to that slide. One moment. Okay, I think we're referring here to this slide. Yeah, so this is really, again, combining two things, looking at the existing solar potential in these places. And so when you think about where is the sun, we say the solar resource the best, the Southwest is really key for that. But we're also looking at how much water is available, because if there's no water available in some of these states, then you can't put floating solar there. So we're combining those two factors, and you can see that the most potential is certainly in the Southwest, into California, but then you have these kind of strange outliers like Minnesota and Florida as well. But these places, let's take the Dakotas for example, where there's not a lot of potential for floating solar, is because of the poor solar resource and the lack of suitable water bodies per our methodology. And so you can read a lot of about the details of that methodology and kind of our assumptions there.
Let's see, there's a question from Suzanne. There is an area in the North Carolina Piedmont that had high land cost. Is North Carolina looking at a pilot for this type of project now? I do know that Duke Energy is building a floating system at Fort Bragg, but I don't know if you want to speak to the North Carolina question that just came in.
Yeah, I'm not sure of projects right now going on in North Carolina.
Okay.
So there certainly could be. I know we're partnering right now with the Bureau of Reclamation in looking at a couple of sites in New Mexico, some reservoirs they have there where they want to put floating solar systems. And we're also working with some partners out of Florida and California. But again, you have these small projects throughout the US, and 2 years ago, we helped with that project in Walden, Colorado, a very small system, but there's a lot we probably don't know about.
Yeah, and I will be sending everyone a follow-up email with links to the North Carolina systems that I know about, and also links to the some of the resources that Ms. Aznar mentioned today. And then also some of the teachers want to know if you're willing to share your slides. Can I forward them your presentation slides?
Yeah, let me just maybe send you if we can touch base offline, Dana, I can send you a version that you can.
Okay, sounds good. Yeah, see, and then can you go back to the slide that I had sent you with the different pros and cons? I think there's a number of questions that we could kind of address in using this. One question is just, what is the typical megawatt output of a floating solar farm? Is the size, can it be the same as a land farm, or is there kind of a standard?
Sure. So, you know, theoretically, this is just going to be constrained by the amount of water, the amount of space you have, right? It's very similar to a land-based system, the amount of space and how much you want to pay for this system. And so, but typically these have been smaller deployments. The largest one is 40 megawatts in China, but you see quite a range. I'm not sure, I don't know if this slide had those ranges.
Oh yeah.
No, this is cumulative in capacity. Okay. I think it had some previous numbers that showed the range of the size of those systems. And so there's not really a typical one. I'd say earlier on they were smaller, partly because they were on smaller water bodies and because this is an emerging technology. So folks were still trying to get familiar with the technology before you make a huge investment in a project. But the capacity in terms of megawatts is increasing over the years. So you do see more comfort with these kinds of systems. They seem to be performing, and so people are building larger systems. But it's quite analogous to how you'd approach a land-based system in that respect. You know, what are the energy needs that need to be met, and what's the cost, and the available land or water.
Mm-hmm. And then some questions came in about animals getting, trapped in the kind of floating infrastructure. And also another question came in about, I think your comment about improving water quality. I think, so maybe just speaking to some of the water,
Sure.
the underlying connections here.
Yeah, so I haven't, again, not a lot of research out there, but I haven't read of significant impacts to wildlife, whether that's fish or other animals getting caught up in the system per se. These don't typically cover large portions of the water body, so it's not like you're putting panels over the entire water body. It's just a certain, fairly small area of the water body. And you could think of it like you would a dock, for example, because they are placed on the same kinds of structures. So you could have comparable environmental impacts, but again, we don't know the details.
Yeah, I think that's something we want our students to really understand, is that there's a lot of research that needs to be done, to understand what some of these challenges might be so that you can better evaluate the trade-offs.
Right. Yeah, and then that question about algal growth, there's evidence that these systems can help actually cool the water as well, directly underneath, protecting from that direct sunlight, and that could have an effect on algal growth, which is really a problem in a lot of water bodies.
Okay, good. So that's the connection. So the cooler water, less algal growth, better water quality. Okay, good. Yeah, I don't know if that's helpful to have that fleshed out a little bit more. And then, and you might have already said this and I missed it, but these are pretty much only can be deployed like on inland surface water, not in the ocean, right?
That's right. We only have I know of, I think 2 or 3 pilots that are in sort of protected bays. So there are on, technically open ocean, but those are not commercially available. There's just a lot of technical challenges with that.
Okay. Yeah, we had other questions. We had a couple questions about, can these platform floating systems be done in conjunction with other energy sources? And you talked about hydropower. Are there any other energy sources that they could be paired with? And I guess the infrastructure can be, maybe speaking to the connection infrastructure. I think there was a question about how many more power lines does this entail?
So, when you're thinking about any energy project, a main factor that influences the cost is your proximity to existing infrastructure, electricity infrastructure, substations, transmission lines, et cetera. And so that goes into any renewable energy project, whether it's a land-based solar system or a large wind system. You're looking at the places where you could connect cost effectively. And so what you're not going to see typically is these floating solar systems in a body of water in the middle of nowhere that's very far away from any sort of transmission lines, right? Because that's just not very practical. And so you're typically going to see these deployed next to existing infrastructure, which means you don't have to build new transmission lines. You don't have to build a lot of that additional equipment. And that's just cost effective. Yeah,
that makes a lot of sense to do that. Thinking about, so that's something our teachers could do with their students, is look at where in our state, could these types of systems be put in the sense of where they can tap into existing infrastructure. Let me just glance at some questions. I know we're not going to have time to get to all of these. Julia had asked about Tennessee being low with FPV potential. Did you know why that might be? Right.
Yeah, I don't know the details. Sometimes when we get questions like that, it may be because we were really conservative with our methodology and the kind of, we looked at ownership of the water body and what the main designated use was. And so if a use is recreation, or I can't recall off the top of my head some of the other uses that we sort of eliminated from our the eligible water bodies. And so this is, again, just to be conservative. It doesn't mean you couldn't necessarily put these systems on some of those other water bodies.
Yeah, that's helpful. And someone offered that, Tennessee, a lot of their water is used for recreation, as is Alabama. So that's interesting. And again, teachers could have their students think about what all those different layers were that were evaluated to determine potential. So we're
Yeah,
right
and we
at the,
also,
go ahead.
oh, sorry. Yeah, we were looking at kind of a data set of national dams and federal water bodies. So we didn't even look at, smaller water bodies that are on private land necessarily. So there could be a lot more. We could be underestimating that potential significantly, but we did that intentionally to be conservative.
Yeah, and I guess that gets to my last question, which some people had, which is who is building these? Are they companies? Are they utilities? Are they countries doing it as, municipal projects? Maybe the answer varies.
Yeah, the answer really varies. When we're working around the world, particularly in Southeast Asia, a lot of the countries there have significant renewable energy targets. And so some of usually those have national utilities. They're looking at deploying these systems. But you also see some utilities in the US, like in Orlando, they're deploying some of these systems. And you could certainly have, private developers deploying these as well.
Yeah.
So it's all over the board.
Yeah, good. Well, I just want to thank you so much for joining us today, and I appreciate everyone being, actively participating. We have a lot of teachers on the call, and I know a lot of students, and I will be sending the teachers, the list of participants so they can see which of their students participated today. And I'll be sending a follow-up email with resources from today's session. There are a lot of really neat stories and aerial footage and videos that you could incorporate into your teaching as well to introduce this topic to your students. And we will draw door prizes as well from the list of participants today. So I'll be following up with you. We will draw 2 teachers and 2 student names. We will be sending out door prizes depending on who you are, whether it's a Vernier solar exploration kit or a solar phone charger. So I want to thank everyone for being here. And are you okay if I include your email, Alex, in the follow-up email in case people want to follow up with you with questions?
Sure.
Okay, excellent. Well, thanks everybody. I'll stick around for just a few minutes if anyone wants to stay on and ask additional questions, but I'm going to stop recording, and I hope you have a wonderful rest of your day today. Thanks again.
Great. Thanks. Bye.
Bye.